fifth question is write the following function in the simplest form. Simplest form, you have to convert this into simplest form, tan inverse 1 plus x square minus 1 upon x. So in these types of question we have to substitute something in this so as to make the function in the simplest form. So whenever there is something a square plus x square, whenever there is x square minus a square minus x square, and a minus x minus a, or you can say a minus x. In these types of problems, we have to substitute generally x is equals to a tan theta, a cot theta. In this type, we can substitute x equals to a sec theta or a cosec theta. A square minus x square, in this case a sin theta or a cos theta. X minus a, in this type we can substitute a cos theta. X is equals to x minus a, in this case we can substitute a cos theta or a cos 2 theta. Like if this is the format, इस तरह से देखा हो या कुछ रूप में हो, so what we can substitute this a cos a plus x, or you can say a minus x. So here when you substitute a cos theta, so this will be a plus a cos theta and a 1 plus cos theta. So what you can do, you can apply this cos 2 theta formula. This is 2 cos square theta minus 1. So in this way it can be simplified further. So if a minus x is there, so you can write a minus a cos theta. So a 1 minus cos theta, and then 1 minus cos theta. One more formula is there, 1 minus 2 sin square theta. So in this way, whenever these types, these are coming the functions in inverse trigonometric functions, so we can put these types of substitution. These types of substitution we can do, and then the question will be simplified easily. So now in this question, put x equals to, this is a square plus x square, so I am putting x equals to tan theta. So this will be tan inverse 1 plus tan square theta minus 1 upon tan theta. So this is tan inverse sec square theta minus 1 upon tan theta, and sec theta is 1 upon cos minus 1 upon sin upon cos. Tan inverse 1 minus cos upon sin theta. Both cos theta can be cancelled out. So 1 minus cos theta, that is a trigonometric formula. Cos 2 theta is 2 cos square theta minus 1, and 1 minus cos 2 theta formula is 1 minus 2 sin square theta. If there is double angle and this side will be half of this. So cos theta will be 1 minus cos theta will be 2 sin square theta by 2 according to this formula. And sin theta, there is a formula sin 2 theta, 2 sin theta cos theta. Sin theta will be 2 sin theta upon 2 cos theta upon 2. Tan inverse. So 2 and 2 cancel out, 1 power is cancelled out. So tan inverse. So now tan inverse tan theta upon 2. And tan inverse tan x is x when that x lies between minus pi by 2 open interval to pi by 2. So this is theta by 2. By default, all the questions in your CBSE board pattern, up to board pattern, they are come within their principal value, principal range. So if you are not showing also, then also your question can be treated as correct. Your answer is treated as correct. So theta upon 2. Theta is, from this case, theta is tan inverse x. So we can put here tan inverse x upon 2. So this is the simplified form. Write the following function in the simplest form. We have to convert in the simplest form. Whenever I have told you that this is coming in the question, so we have to substitute x is equals to either a cosec theta or a sec theta. It's depend on the question. So same, this is x square minus here a is 1 square means x square minus a square format. So we will try first of all at x equals to a cosec, x equals to only cosec theta. So tan inverse, this will be cosec square theta minus 1 square root. And tan inverse, this is by the identity, third identity, this will be 1 upon cos square theta under root. So this is tan inverse 1 upon cot theta, which is tan inverse, which is tan inverse 1 upon cot is tan. So we can write this theta as if theta should lie between minus pi by 2 to pi by 2 open interval. This theta, we can write this theta should belongs to minus pi by 2 to pi by 2. Then only we can write. And in all the questions in your NCERT CBSE board level, they had given the question accordingly, means whatever you will substitute in this, they will automatically come in and the validity need not to be checked. But I will check in this question. This theta, the value of theta is here cosec inverse x. So answer is cosec inverse x. Now for validation part, more x is greater than 1 means x is either greater than 1 or x is less than minus 1. In this case, cosec theta is greater than 1, cosec theta is less than minus 1. We cannot take equals to 1. Actually, this is the, so this is the cosec theta is greater than 1, cosec theta is less than minus 1. We show the theta is greater than pi by 2 and here theta is less than minus pi by 2. This is for the case of cosec theta, means our cosec theta is lies between this minus pi, cosec theta is greater than 1 or cosec theta is less than minus 1. Cosec theta is 1 upon sin theta. 1 upon sin theta is greater than 1. Cosec theta is this. So sin theta will be less than 1. So theta is less than pi by 2. Similarly, here 1 upon sin theta is less than minus 1. So sin theta is greater than minus 1 means theta is greater than minus pi by 2. So it clearly shows that this is our theta is lies in this interval. We cannot take x equals to 1. Actually, you know that the sin theta function in trigonometry is the range of this inverse trigonometric function of sine is minus pi by 2 to pi by 2. But we cannot include pi by 2 in this, because if we include the pi by 2, it will reach to infinite. So this is ranges in this interval. So our answer is this. The validation is true. So come on, next question. So our question number 7 is write the following functions in simplest form. Tan inverse 1 minus root 1 minus cos x upon 1 plus cos x in whole square root. So first of all, we will apply the formula, that is cos 2x. Cos 2x formula is 2 cos square x minus 1 and 1 minus 2 sine square x. So here is double angle, so there is half of this angle. So it means now we can use this formula in this part. 1 minus cos x. So this will be 2 sine square x upon 2 because there is already 1 x. So the angle will be half. And 1 plus cos x is 2 cos square x upon 2. So this is tan inverse root tan square x by 2. So now as this is x is defined as less than pi. So if x is positive in this, then root of tan square x by 2 will be positive tan x by 2. If x is negative, then tan square x by 2 is minus tan x by 2. So we will take positive in this. So this will be tan inverse tan x by 2, and this is equals to x by 2 as. Now we have to check because tan inverse tan x is x, where x should belong to minus pi by 2 to pi by 2. So similarly x upon 2 should also belong to this interval minus pi by 2 to pi by 2 open interval. This should belong to minus pi by 2 to pi by 2. As we are taking only positive side of this. Positive side we are taking means 0 to pi x. So x is 0 to pi. So x by 2 will be pi by 2, and 0 upon 2 is 0. So 0 to pi by 2 is clearly lie in this interval. So we can write this in the simple form is equal to x upon 2, and this is our answer. So question number 8 you will do yourself. Now question number 9 is tan inverse x upon square root of a square minus x square plus more x. This is the value of x given in this domain is given, which is more x is less than a. For checking the validity part, means we have to consider this, and then in the last step this is coming in this or not. Means we can simplify this or not, because ultimately there should come something tan, so the tan must should be simplified out, and we can get our final answer. So in this same substitution we will do in this. So either x, because this is a square minus x square. So either put x equals to a sin theta or a cos theta. So I am putting here x is equals to a sin theta, because this will be beneficial for you, because easily you will get tan theta in this. So tan inverse a sin theta upon a square minus a square sin square theta and square root. A square you can take common and there is square root, so a will come outside and this a and a will be cancelled out. And now tan inverse sin theta upon 1 minus sin square theta ka square root. 1 minus sin square theta is cos square theta, and there is square root. So you can write tan inverse sin theta upon cos square theta ka square root, and tan inverse sin theta upon cos theta. So this is tan inverse tan theta, and this is equals to theta. But we have supposed here theta we had supposed here x is equals to, we had put here a sin theta. So therefore theta, first of all we will transpose this, and then theta will be equals to sin inverse x upon a. So our answer is sin inverse x upon a. What we have to check? We have to check the validity of this. Now we have to check the validity rather, because we cannot write this theta if our theta is not belonging to minus pi by 2 to pi by 2. Our theta should belong to this interval. This is here theta is principal range of this tan inverse function and the domain for simple trigonometric function. So now mod x is less than a means minus a, x is greater than minus a and less than positive a. So now what is x? X is a sin theta. Now divide by a in this inequality, you will get minus 1 and here positive 1. When you take the sin inverse of minus 1, you will get minus pi by 2 and this is positive pi by 2. What is here? Theta is here. So this theta is coming in the range of minus pi by 2 to pi by 2, and which is the same principal range for tan inverse function. So that's why we can write this tan inverse and tan theta as theta, because it is clearly coming in the principal range of tan inverse x function. So this is our answer. So question number 10, this is tan inverse 3a square x and minus x cube upon a cube minus 3a x square. A x is lies in this range. So you have to convert this into simplest form. Inside there is something should come in terms of tan, because then you can simplify this easily. 2 theta, 3 theta, anything should come, and then we have to check the validation of this using this, whether we can write this into, suppose the 3 theta is coming. So 3 theta we have to check, this 3 theta should lie in the principal range of in tan inverse function. So if you have learned very well all the formulas which you have studied in class 11th trigonometry, then you can easily you can check this, that if we put x is equals to a tan theta, this will become the formula of tan 3 theta. So tan inverse 3a square a tan theta a cube tan cube theta upon a cube minus 3a into a square tan square theta. Here is a cube, a cube, a cube, a cube. All the a cube can be cancelled out by taking common. So this will become tan inverse 3 tan theta minus tan cube theta upon 1 minus 3 tan square theta. And this is nothing but the formula of tan 3 theta. So we can write this as tan inverse and which is equal to 3 theta, where 3 theta should belongs to minus pi by 2 to pi by 2, and value of theta is from this x upon a is tan theta, and our theta is tan inverse x upon a. So here we can write theta, value of theta is tan inverse x upon a, which is the answer. Now we have to check the validation. X is in the NCERT, it is given less than equals to in some books, but this is wrong, because you cannot take value x equals to a by root 3. This will become infinite, so which is not allowed. So a by root 3 to minus a by root 3 to positive a by root 3. Now what is x? X is, we have put a tan theta. So divide by a both sides. So this will be minus 1 by root 3 tan theta to positive 1 by root 3. Now tan inverse of negative 1 by root 3. Tan inverse of negative 1 by root 3 is minus 5 by 6. And this is positive 5 by 6. Tan theta is 1 by root 3 and here is minus 5 by 6. Now what is negative? 3 theta. So multiply by 3. On doing the multiplication of by 3, you will get here 2, 3 theta and here 2. It means this is coming in the principal range of this tan inverse x function minus pi by 2 to pi by 2. Clearly you can check. So in this way we can write this as 3 theta and then finally the value of theta is 3 tan inverse xy and this is our answer. Now question number 11. Up from question number 11 onwards you have to find the value of each of the point. In some questions you have to find the values now. You don't have to simplify. Now you have to find the value. So tan inverse. First of all we will start from inside. In this function 2 cos 2. So what is the value of sine inverse 1 by 2? Sine inverse 1 by 2. So sine inverse 1 by 2 coming on angle 30 degree, which is pi upon 6. So this is equal to pi by 6 and this is coming in the principal range of this sine inverse trigonometric function. So we can write at the place of this pi by 6. Now 2 multiplied by pi by 6 is pi by 3. 2 multiplied by pi by 6 is pi by 3. So this is tan inverse 2 cos pi by 3. Now what is the value of cos pi by 3 means cos 60 degree, that is value half. So tan inverse 2 multiplied by half. So now this is tan inverse 1. So now you have to find out at what value this tan what is the means finally value of this tan inverse 1. Tan inverse 1 means tan pi by 4. Tan inverse tan 1 is coming on tan 45 degree. So tan inverse is pi by 4 and this pi by 4 belongs to this pi by 4 is belongs to principal range of minus pi by 2 to pi by 2. So this is finally answer the value of this question. So this is a very simple question. For we have to find the value of this by the property tan inverse x plus cot inverse x is equals to pi by 2. Using this property where x belongs to real number. So same thing in this tan inverse a plus cot inverse a is also pi by 2. So cot pi by 2. Now we have to write the answer of this cot 90 degree. Cot 90 is cos 90 upon sin 90 degree. And sin 90 is not cos 90 is 0. So this answer is 0. This is the final answer.